cubed plus 5m squared minus 2m minus 16. And off to the side here, I am going to multiply my divisor, m plus 2, by something to get m cubed. So I need m squared, right? There's my m squared. I get my m cubed. Don't forget you have to distribute it to the 2. So I get a plus 2m squared plus 2m squared. I'm subtracting that quantity. These eliminate. 5m squared minus 2m squared, 3m squared. Going to bring down the minus 2m. Then I'm going to take my divisor, m plus 2, multiply it by something to get 3m squared. So I need a 3 and an m. Let's see, plus 3m, 3m squared. Distribute it. So I get 6m. Going to subtract the entire quantity. These eliminate. Let's see, negative 2m minus 6m minus 8m. Bring down the minus 16. I'm going to take my m plus 2, multiply it by something to get negative 8m. So I need a negative 8. Distribute negative 8 to positive 2, negative 16. When I subtract this entire quantity, all of this eliminates to 0. So I have no remainder. So my answer, m squared plus 3m minus 8. And there you go. Questions? Yes, ma'am. The m squared, this one? The answer? Oh, it's up here. All right, synthetic division. This time we need the actual 0, not the factor. Remember, we have to set that equal to 0. Solve for n. So this is my divisor, negative 9. Now I need the coefficients of my polynomial. I have 7, 72, 81, and I'm going to put the 0 in there for the constant. Bring down the 7, multiply it to the negative 9. I get negative 63. These I'm going to add. 72 plus a negative 63 is a positive 9. Multiply it to negative 9, get a negative 81, and that gives me 0. So I didn't need that 0. So I started with an n cubed, so I end up with a 7n squared plus 9n. And it only asks us to divide it once, so I'm done. Questions? Okay, number 13. So my divisor here is 8. My coefficients, good. Negative 19, negative 43. Bring down the 3, multiply to the 8, 24, add negative 19 and 24, positive 5 times 8, 40. So I get a negative 3 when I add them. That means I'm going to have a remainder, right? So I have 3. I started with x squared, so 3x to the first plus 5 minus my remainder 3. This time I have to put it over the divisor, the factor, x minus 8. Now that was kind of the boring stuff we did, right? Now comes the fun stuff. Just the start of it. Fundamental theorem of algebra, right? Okay, I got to get some water for this one. Okay, fundamental theorem of algebra. We got to find we has to find all the zeros, right? Has to finds. I'm a what you call an English major. All right, grab your handy dandy calculators, right? See, we got x cubed. Don't everybody rush to the because you can only fit so many students in the calculator area. So be careful. Don't trample anybody. X cubed plus 5x squared plus 4x plus 20. I feel so lonely. I feel like I'm the only person that does this. Graph it. How many real zeros do I have? 1. I have 3 zeros, right? Did we answer those questions? Oh, I did it last hour. How do you determine how many solution a polynomial has? You look at the degree of the polynomial, right? Or in other words, the highest degree. Write an example of a polynomial with 4 solutions. Don't overthink this. X to the 4th has 4 solutions, right? If you want, you can put all kinds of numbers in here afterwards. Just don't go higher than 4. So on this one, I know I have 1 real 0 because it crosses my x-axis once. And hopefully I can find it easily on my chart. I'm looking for a y value. There it is right there. A y value is 0. That means I have an x intercept at -5. That's one of my zeros. Which is telling me, what are my other two solutions? What are they? Going to be imaginary numbers, right? So guess what we get to use, unless you're noticed a pattern that of something I taught you earlier. That's right, the quadratic formula. So let's start dividing. Here's my divisor, -5. Let's see my coefficients of my polynomial. Now, if you like it underneath, you can certainly do it underneath. Let's see, I have a coefficient of 1, 5, 4, and 20. Bring down the 1. Multiply to -5. -5 plus 5, 0 times -5, 0 plus 4, 4 times -5, -20 plus 20, 0. So I'm down to x squared. This is my x to the first. If you want to put a 0 term there, by all means, go ahead. Then I have a plus 4. Can I factor this?
Yeah.
What is it?
Wouldn't it be 2 and then in parentheses x plus, or no, you can square it like that. X plus 2 in parentheses and then square.
So x plus 2 squared, which is just x plus 2 plus times x plus 2.
Mm-hmm.
That's x plus 2 squared, right? Well, let's FOIL this out. X times x is x squared. Outer x times 2 is 2x. Inner 2 times x, 2x. 2 times 2 is 4. So I get x squared combined plus 4x plus 4. So that doesn't work, right? Because this is not the same as that. Want to try x?
Or, oh no, what is it, 2 negatives?
2 negatives?
I don't know.
No, I see what you're trying to do. You're trying to get. You notice that this is a perfect square and that's a perfect square. It's 2 squared, right? You're trying to factor this using the perfect squares formula. But you can't, because this is not. You have to have a difference. You have to have a minus sign there. That's why you can't. Remember back when we graphed this, we only had one real solution. So, what's the other methods to come up with imaginary solutions? We can't factor it. We have to use quadratic formula and or completing the square, right? There's another method that's 10 times easier, but I'm not telling you what it is because I taught it to you already. I'm a mean, cruel person. Bless you. So I'm going to use quadratic formula. My A is 1, right? And Jared, I'm putting you in charge to try to figure out what that short way is. B is 0. C 4. Okay, quadratic formula, unless you want to use completing square. Negative b, which is -0 plus or minus the square root of b squared minus 4ac all over 2 times a is 1. Going to do the square root off to the side. Don't need the 0 squared. Minus 4 times 4 is 16. 16 is a perfect square, right? Square root of 16 is 4. Square root of negative 1 is I. So I'm going to take this 4i, replace it for that whole square root thing. I get x equals, don't need the negative 0 there, do need the plus or minus sign. And for this whole thing, I'm replacing it with 4i, all divided by 2. I can factor out a 2, right? 2 and 1. So I have plus or minus 2i. There's my other 2 zeros. Plus or minus 2i. Now you guys are ready for some fun, right? We're going to put all this into action and have some fun with graphs. Fun with graphs. Funner stuff. I was telling my last class, this is like video games. This is my controller right here. See?
They weren't into it either.
They're doing the same thing that you are. All right, so I'm going to go ahead, put my polynomial in there. So I have a negative x cubed. Don't use a minus sign.
I've done that way too many times. I want to break something here.
You play video games?
What? No, I said I actually used the minus sign instead of the negative.
Oh yeah. I've done that a couple of times myself. It does drive you. You want to just throw the calculator against the wall, don't you?
Yeah, because it doesn't look like anything's wrong. But
Yeah.
You're like, oh wait.
Okay, so negative x cubed plus 4x squared minus x plus 5. Graph it. And there it is. Oh, wonderful. Let's get some points. Let's see. I can use negative 111, negative 111, 0, 5, 1, 7, 2, 11, and 3, 11. So that means our turning point is between 2 and 3, right? Because they both have 11 for a y. And then 4, 1. All right, let's try this. Comes to the top. I have a turning point here. Looks to be 0, 5. Then we have a turning point somewhere between 2 and 3. And then back down here to 4 and 1. So that looks pretty good. All right, let's find our zeros. Now, this is where you can think of it as a video game, right? Think of it as, the Mario going on the mushroom thing trip, right? X intercepts. So I gotta go to second trace. Find the 0. And looks like I only got the 1 here, right? See? Enter. Enter. I wish I could make a jump. Enter again. And the 0 is 5.1 or 4.1, comma 0. Turning points, the max. So, huh? So the max. Let's see. Oh, I'm not going to be able to see it. That's okay. I'm going to hit enter. I'm to the left of it. Going to get to the right of it. Enter. Enter again. And I get 2.5 and 11.9. My min. Let's see, where's my cursor? Oh, there it is. There's my minimum. So left bound enter, right bound enter, enter again. I get 0.1 and 4.9. All right, so it wasn't quite 5. Okay, let's split up our axes with those turning points, okay? So I got 2.5. So x equals 2.5. And then x equal 0.1. Wow, another close one here. X equal 0.1. Okay, so it splits up my x-axis 3 points, right? Oh boy, let's color. Bet you your video games don't do this, do they? Oh, they probably do. Back in the day, they didn't for me. Okay, it starts here at negative infinity, goes to my first turning point x value, 0.1. Then I got from 0.1 to 2.5. Then I got 2.5 out to 1,000. And you know what's really great about my video games with the calculator?
What?
It's free.
Is it? How much
So
is
I'll
the
free.
calculator, though?
No, I'll supply it for you. We'll supply it to you. It's free. Get rid of your Xbox. Get rid of your PlayStation. It's calculator time. All right, I'm gonna go ahead and write down.
Watch out, you might get to a point where you can't say calculator right.
I've been using calculators for so long, I don't even know if I can. Okay, so my intervals here: negative infinity to 0.1. So I'm going to have 0.1 to 2.5. And then I'm going to have 2.5 to positive infinity. Okay, so here's my starting point. Starts way up here, goes down, so it decreases here, right? Decrease. It's turning point, increase. It's turning point, decrease. Okay, all I have to do is just put them in here now. So increasing 0.1 to 2.5. decreasing, negative infinity, 0.1. And since there's going to be two of them, I need the union sign. 2.5 to infinity. And then we need end behavior. So as x goes to the left, or negative infinity, what happens to my y? Positive infinity. As x goes to the right, positive infinity, my y goes to negative infinity. Now, you can't tell me that modern warfare is funner than this.
Wow, it's amazing. It's amazing that you're not.
I mean, there's no factors in it.
Warfare.
I was talking about the funnies, right? Or what? Wait, did you say good or?
Quitter?
Did you say funner or gooder?
They're both funner and gooder.
It's better than Warzone.
It's the funnest. It's a festival of fun.